All right, so this probably looks pretty familiar to some of you. We're using chillers in this situation. Okay, we have a cooling tower. Everyone here has a cooling tower, right? Or obviously not the water stripless guys, so you know how this works. Typically we like to monitor makeup, we like to monitor blowdown, all back to this control system. Okay, so here's kind of like our general feed. We're pulling off the return, returning it back into what we consider a sump. And we, like boilers, have 3 chemical system, 1 inhibitor, and then we feed a 2 biocide program. And we'll get more into biocides later. Any questions about a typical boiler or a cooling tower system? It's pretty standard. All right, so different processes in plants. So what processes do each of you have that require cooling? So like we talked about in boilers, I don't know, were you going to hand out a sheet for this, or? It's on there, okay.
Yeah, we can stop and
Perfect.
go through and write it down.
Okay. So yeah, assuming like we talked about for boiler systems, it's going to be HVAC related. Anyone use chillers for process other than Millipore Sigma? Okay. So you're going to be cooling something other than air handling units. But again, here's just kind of a layout. Chillers, heat exchangers, and then we'll get into how they work.
Go around and
You want to talk about?
Yeah. Especially if you have something other than HVAC. But
Yeah.
HVAC, obviously air conditioning for your space, but we go around the room again, just like you did with the boilers, and explain what your systems are used for.
We'll start up here.
Cooling kind of things that we're just using some of our die casting processes.
Die cast.
Yeah, use them in cooling rolls with process.
No, it's not.
Moral story. WPS included, yeah. You guys use it probably for reactors.
Yeah, we use it on the reactors and systems for the kettles and tanks.
Cool. So it's going to be a similar process for whatever you're cooling. Just obviously at the end, whatever you're cooling is going to be a little different. So here, just insert for those using for HVAC, obviously air handling. For those who are using it for process, that'd be like your vats for chemical treatment or for chemical formation, that kind of thing. So again, it's all about rejecting heat. So that's why we put in cooling towers. Okay, allows us to cycle up. Number 1, reduce, reuse, recycle water, and 2, it's a great heat rejector. So here's just kind of a typical rundown of a facility. Pretty standard. Again, here's how a chiller works. Okay, again, we're talking about heat being released. You're gaining heat from something, whether it be your air handlers, your big chemical reactors, goes through your chiller with whether it be a heat transfer fluid like glycol, Freon, or if you're a food production facility, ammonia. That's what's doing the cooling. That's what needs to be cooled, actually. So we'll get in with chilled water loops. They may seem easy to treat, but sometimes they aren't. Corrosion is our biggest worry when it comes to these. Okay, we do feed a scaling corrosion inhibitor like we talked about earlier. It is a closed loop, so it shouldn't change, but I know in processes like die cast shops where there's leaks, whether that be in your cooling tower system or in your closed loop, you're going to be replacing water all the time. So scale obviously a little less likely, but if you're working with really high temperatures, like maybe in a vat or die cast shop, you're going to have some scaling issues. So then particulate we talked about too, about side stream filtration, and then a little more difficult to handle is microbiological growth. We don't typically feed a biocide to a closed loop. That's typically reactionary. So again, I talked about it down here. Here are the three main things. Make sure your corrosion inhibitor is in range. Filtration is key. If you have a ton of sediment, you're going to have major corrosion problems. And then typically we feed a biocide only when we run some biological counts and we find that it's higher than normal. But it's those weird temperatures like 60 to 100 degrees that cause your biological problems. So typically hot water boilers, not an issue, or really cold water systems, also not a major issue. So cooling towers. Looks familiar. I always thought that was steam. Yeah. Until I got in the industry and I'm like, oh, those are actually cooling towers. So the purpose, like I talked about earlier, reduce, reuse, and recycle water. If these are used properly, they really are. We're working right now with a place up north that doesn't have it. It's a once-through system. Really a nightmare. So you talk about water in, water out, not cycling up, not getting the most out of their equipment, very expensive. So the cost for a good cooling tower, not only are you going to be better stewards of the environment, you're going to save yourself some money. So two types of towers. Induced draft, typically, it's where you have the fan on top. Most of you probably have that. And then forced draft. So that's really it for cooling towers. I know I blazed through that pretty quick, but it's pretty standard stuff for you guys. I don't know if there's any questions specifically about what we covered, but we'll get into a little bit more of the problem areas with cooling systems later. Cool?